Hi there. In this video, we're going to be talking about a machine learning method of regression called k-nearest neighbors. This is a very simple model and it requires just a basic knowledge of statistics. This model can be done by someone in the 10th grade in high school. All you need to know is how to calculate the mean, standard deviation, and how to use the theorem of Pythagoras. Machine learning in general can be done by anyone. You don't need advanced programming skills. In this particular video, I'm going to show you how this KNN model works and afterward how you can easily apply it to anything using Microsoft Excel. The reason why I'm using Microsoft Excel is because it's a widely used program by professionals in a lot of fields, and many of these professionals might not have studied programming. Since Excel is already familiar to so many people, learning to do machine learning in Excel can actually be a great first step towards understanding these methods. So if you do find this video useful, please like, share, and subscribe to this channel. And also, by the way, the spreadsheet that we developed in this video, it's available in the description as a Google Drive link. So you can download it and use it as sort of a template. So we're going to start with a relationship between three variables. So we have x1, and x1 represents the size of a house in square meters, and x2 is the number of rooms in the house. So we're going to take this information and we're going to try and get an indication of the energy consumption of that particular household, and this is measured in kilowatt hours. So here x1 and x2 are input variables, and we use it into the model and we get an output that's the energy, and that's what we want to predict. So we have data that we have collected from a variety of different places. In fact, we can say that this data is coming from three different categories. That's apartments, townhouses, and freestanding houses. So we go to all of these different places, we categorize it into these three categories, and then we order this information into the size of the house and the number of rooms, and that becomes our input data set. And we're going to use that to develop a model and correlate that to the household energy consumption using this k-nearest neighbor. So it's important to categorize this data because what they do is that they introduce some structure into the data. Energy consumption patterns might be different for an apartment compared to a freestanding house, even if they have the same number of rooms and square area. So this is just an illustration, an example, a situation where we might have to use this kind of model. We would use a similar model later on in this video to actually demonstrate the method. So to understand how this model k-nearest neighbor works, let's use an analogy. So imagine you've just moved into a new neighborhood and you want to find out in this neighborhood where the best local cafe is. What do? You ask your nearest neighbors. If most of them recommend a particular cafe, then you're more likely to trust that recommendation. So the algorithm works in a very similar way. So what we do is we have our information that we've gathered, that's the data sets, and now we have a new data point. So we have some kind of size of the house and the number of rooms, and what we want to do is we want to use our model that we've trained using the information we gathered to estimate, if we just have a random house that we find, what is the energy, what we want to predict, what is the household energy consumption. We want to estimate it for our new data point, and we want to base that prediction that we get on similar houses. So now let's look at how this method actually works. What is the algorithm and what is the thought process and the logic that goes behind implementing it? So we'll use the same situation where we discussed. We have these two input variables, x1 and x2. What we're going to do is we're going to firstly do a scatter plot. On the x-axis, we're going to have x1, that's the size of the house, and we're going to plot that against x2, that's the number of rooms. So let's just say we have data for 12 houses, and there's 4 data points in each category. You'd remember the categories being apartments and freestanding houses and so on. So let's just say the pinkish points that we have just plotted now, they are in category 1, and this is the data from apartments. And then we plot another category. These are the yellow points, and we'll say that is from category 2, that's from the townhouses. And then the third category of points, this is this bluish set of points, they are from category 3, freestanding houses. So now we have this scatter plot. So we want to consider a new point where we know what x1 and x2 is for that particular house that we're considering, but we don't know what category the house falls in. We don't have the information, and we want to predict the energy consumption for that new data point. So in implementing this KNN algorithm, what we'll need to do is we'll compute the distance between this new point that you've seen in red now, that's indicated by the arrow. We're going to compute the distance between that new point that we want to know about and every other point in the data set. And that distance is specifically the Euclidean distance, which you would remember from high school. And we calculate this Euclidean distance using the Theorem of Pythagoras. So just to remind you, let's just take a point, and that point is at position I, and it has coordinates xi and yi. This is just a random point. And then we have another point at position j, and it has coordinates xj and yj. And then if we wanted to compute the distance between I and j, then what it would be is the square root of xi minus xj squared plus yi minus yj squared. So you can see that xj minus xi is just the x distance between the 2 points, and yj minus yi is just the vertical distance between the 2 points. And then we use Theorem of Pythagoras to calculate the hypotenuse, and that's how we get the distance. So once we compute the distance between our new house that's designated by the red point and all the other existing houses, the next step is to take those distances and sort them in increasing order from smallest to largest. So you can see what I've just displayed now is the distance from that red point to all of the other points, and they have now been sorted in ascending order. So this is where now K comes in. You would recall that the name of this model is K nearest method. So that K refers to a certain value that we choose, and it speaks to how many neighbors we consider. For example, if we choose K equals to 4, then what we're going to do is we're going to look at the 4 nearest houses in that sorted list that we have just done. So there's a few caveats here when we thinking about K, and the first comment that I wanted to make is that if we choose K to be too small, then the prediction is sensitive to noise. And when I say noise, I mean random variations in the data. On the other hand, if K is too large, then what happens is that the prediction becomes too generalized and may not capture local patterns in the data. So what people typically do is they would choose different values of K, and then they would select a certain value of K that gives the best predictions. So in the case of classification problems, if we wanted to see which category this new point falls in, what we would do is we would check that, okay, category 1, it appears twice. You can see that the pinkish data point in the first 4 data points that have just been highlighted now, you can see that that pinkish points appear twice. So what we would do is we would predict that this house is in that particular category. It's an apartment, in other words. In the case of regression, what we would do is we would estimate the unknown value of the energy consumption by simply taking the average of the energy values of those K nearest points. So we would take the energies, the household energy consumption of those 4 nearest points, and we would take the average of it, and that would form our prediction of the energy consumption of this new data point that we are looking at. So to summarize this algorithm in general, what we want to do is we identify a point that we want to predict some information about it. We would then compute the distance, the Euclidean distance between this point and every other point, and then we would sort those distances in increasing order. We would then choose a value of K, and then to find something that we are predicting, in this case, the energy consumption, what we'll do is we will take the average of that value for those nearest neighbors, the K nearest neighbors, and we would get that predicted value. So what's coming up next is we're going to implement this method in Microsoft Excel. Now that we understand how this k-nearest nearest neighbors works, let's see how we can actually implement it in Excel step by step. So here we are in Microsoft Excel, and we have our input data set here. So this is the number of rooms, the number of residents, the average temperature. And for each of these different houses, we have an energy consumption associated with it. So we have about 20 data points, and we want to use this information to generate our KNN model and use it to predict for a house that we know these input variables, the number of rooms, number of residents, and average temperature, what would be a predicted energy consumption. So we're now going to implement this KNN model and all of the steps that I have just indicated now in the algorithm. But before we do that, what we need to do is standardize the data. So the reason why we standardize the data is because we can see that these variables are measured in different scales because they are in different units. You can see that this number of rooms, it's actually in units. I mean, we can see that we have between 2 rooms and between 6 rooms. On the other hand, if we look at average temperature of the area, you can see that these values are an order of magnitude larger in terms that they vary between 18.3 and maybe 26.3 and so on. So these values are much larger, and because they're much larger, they could potentially dominate the calculations. They could skew the calculations in some way that might affect the predictions. So what it does is that it creates a level playing field when we standardize this data. So we're going to standardize this data using z-scores. And in order to do that, what we have to do is we have to calculate the mean and standard deviation for both the input and output data sets. So we compute the mean simply by just using the average formula. So then we select the first input data set. We have the average there, that's the mean, and we simply drag that formula across, and that gives us the average for each of these different columns. And then we just do the same thing with the standard deviation. So we calculate the standard deviation of the first column, and then we just take that formula across, and we have it now for all of the different columns. So we can now proceed to standardize the data, and we can go here into this next sheet that we have. You can see it says standardized data here, and we're going to use z-scores. The formula to standardize it is given on the screen. What it's equal to is the observed value, so it's just generically x here. And what we have to do is we subtract the mean of that column from it, and then we divide it by the standard deviation of that column. So if we go to the number of rooms, what we would need to do is we would take our data point, in this case the number of rooms, and then we would subtract from it the mean of that particular column, and then we would divide it by the standard deviation of that column. We can then drag our formula down, and that standardize it for all of the different values. And then we can also drag it across, and it does it for all of the other columns as well. So in this way, we have now standardized our data set. And if we take the mean of this column, the standardized data set, we find that the mean of all of the columns are now 0. So this is a very important step, and we should not neglect it when we do it for whatever data sets that we may be considering in our line of work. So we can now proceed with the KNN calculation, and that's on the next sheet here. So this is our new data point. We have a new house, and this house has 4 rooms. It has 3 residents, and the average temperature in the area is 22 degrees Celsius. So we want to predict the energy consumption. So as previously, what we have to do is we standardize this data point, and we use the same z-score. So we have to take the observed value, we subtract it from the mean, and we divide it by the standard deviation. And then we just drag that formula across, and then we have it for the rest of the information about the data point. That's x2 and x3. So we now proceed with the step of calculating the distances, the Euclidean distances. between our point, our data point, and all the other points. And that's given by the Theorem of Pythagoras formula that we can see here. And we just proceed to implement this formula. So what we have is our new data point, the x value. We're going to say equal to. We take that particular observed value, and then we're going to subtract from our data set. So we go to our standardized data, and we put that in. We should also just be careful to lock the cell of the new data point. And then we square that. And this is added to the next input variable. We take that, we subtract it from our standardized data point, and then we square that as well. And then finally, we do the same with our last point. That's the average temperature. We take that value. We just remember to lock that cell as well. And we subtract it from our data set. And we square that. So there's just one other thing to remember here is that we're taking the square root. So we should not forget to take the square root. So we just put in the formula SQRT, and then we just put brackets around the formula we've just typed. And that gives us the square root. So associated with that distance, we just put in the energy consumption. We go to our standardized data and we just note what it is. And we just drag this formula down. So we have the distances from our new data point to every other data point. And now all we need to do is sort it. We go to data, we go to sort, and this dialog box comes up. So we go sort by columns. We're going to sort by the distances, smallest to largest, and then we press OK. And now we have our sorted distances. So the regressed value, in this case here, we'll choose k equal to 4. So we'll take our first 4 data points, and we'll find the average of that. All we need to do is to convert from our standardized data point back to what the observed value actually was. And then to do that, we have to take the reverse of the standardized formula. So you can see that z is equal to x minus mu over sigma. So all we do is we solve for x. We multiply both sides by sigma, and then add the mean mu to both sides. So when we do that, we get that the observed value is the z value times sigma, the standard deviation, and then we add the mean to it. So in this case here, we'll take this z value that we've just determined, and then we'll multiply it by the standard deviation of that column. That's the energy consumption. We multiply it by the standard deviation, and then we add the mean to it. And we see that value is 415. So that's our result. We can see that now if we take a different household, which has 4 rooms and 3 residents, and is 22 degrees in that area, then we find that our predicted energy consumption is 415 kilowatts. So this is just a simple way of implementing this algorithm in Microsoft Excel. Just to summarize once more, we have our original data set. We find the mean and the standard deviation, and then we use that information to standardize our data set using the z-scores. And then finally, what we do is we take our new data point, something we want to predict. We standardize that data point in the same way as we had done with the data set. We then compute the Euclidean distances. We then sort the Euclidean distances from smallest to largest. We take the average. In this case here, we chose k equal to 4. So we took it for the first 4 data points. And we have our new predicted energy consumption. We then convert the standardized value into our observed value. We saw that's 415. And that is how we use the KNN method, which is a simple method that can be used and we can use it to actually derive accurate predictions in a large number of cases. So thank you very much for watching.